So in this video, I'm going to work through example 14 from section 8.2. How do we figure the desired sample size to produce a certain margin of error? That's what we're going to structure ourselves through. So let's take a look at how this problem is set up. So the company is receiving complaints about its customer service, decides that it wants to go ahead and hire a consultant to run a sample survey on customer service. It's going to take all those answers back. It wants to establish a confidence level for the customer service rating that comes back, the proportion sample result that comes back for the population from the customers. And what they've said is for their confidence interval, they want a 95% confidence interval. They want their margin of error to be no more than 3 percentage points, which in turn is saying they want their their confidence interval to be no bigger than 6 percentage points wide. So a 3% margin of error. So let's talk through how do we go ahead and solve this type of problem. We'll start with our basic fact. Our confidence interval looks like P hat, whatever we get, plus a critical value based on our confidence level times our standard deviation of the population proportion, which is the square root of P hat times 1 minus P hat all over n, that whole thing taken the square root. And the piece that you see right here, that's our margin of error. We want to make that particular piece, I'm going to just scratch out some of what I already have here. We want to let that be less than 0.03, 3%. Now, this CV value is already determined by the confidence level. But what's interesting is, well, how can I go ahead and figure out what value of n to use? I haven't run the sample yet. I have no idea what P hat is. So the book kind of goes through a couple ways as to how you can figure out what this standard error should be. And they give you two options. One is, well, we could just go ahead and take the P hat that we got from a prior survey and run with that. And that's okay. But it kind of begs the question, well, why am I doing this survey if I'm just going to use information from a prior survey? Nothing wrong with that necessarily, but it kind of makes one wonder just a little bit. And so maybe the safest way to do this is kind of take a conservative approach and say, well, you know what? Let me just figure out how big I could possibly make my standard error. I'll kind of figure a worst case value of P hat that would come back when I do go ahead and run this sample. And if I maximize this, if I get any other proportion value, that's fine. I'm going to have even a slightly smaller margin of error. So to a certain extent, I've kind of asked myself, how do I make my standard error as big as possible? And it turns out that just translates into how do I make P hat times 1 minus P hat be as big as possible? And it turns out in the circumstances that we're working at, all we need to do is make P equal to 0.5. That's going to maximize the value. 0.5 times 0.5, 0.25. Do any other value of P hat, and you will always get a product, P hat, 1 minus P hat, will be less than 0.25. So by default, and to be conservative, I'm going to let P hat equal 0.5. Let's go ahead and figure this out now. I want to be at a 95% confidence level according to the problem. So I'll draw, here comes nice little 95% sitting all in that shaded area. If I run inverse norm 0.025 or inverse norm 0.975, what have I done? Well, 2.5% over here, 2.5% over there, 95% hanging right in here. Those inverse normal values map perfectly to my critical value. And that turns out to be, in this case, 1.96. So what do I want to do? I want to make 1.96, and we're going to go ahead and substitute our worst case scenario for making this standard error as big as possible will be 0.5 times 0.5 over n, square root of that, and I want that to be less than 0.03. If I do a little bit of work, this becomes 1.96. Square root of 0.5 times square root of 0.5 becomes nothing more than 0.5 over the square root of n. I'm just kind of handling my numerator here. That's less than 0.03. I'll do a little bit of work. I'll divide by 0.03, multiply each side by square root of n, 1.96, 0.5 over 0.03 is less than the square root of n. And if I walk my way through on the calculator doing that, 1.96 times 0.5 divided by 0.03 will produce 32.66, so on and so forth. It'll just be a repeating decimal, is less than the square root of n. I'm going to square this. 32.66 squared is 1067.1 is less than n. What do I know? Well, if I surveyed 1067.1 customers, I'd be at that level. However, you can't do a survey of 0.1 person, you need a whole person. How do we do this? Round up. Our desired sample size is 1068. So that's the process here. We got to do a little bit of conservative work, we have to do a little bit of detective work, we got to do a little bit of algebra. But we can come up with a desired sample size to produce a given margin of error at a specified confidence level. It's kind of a key point. And kind of remember, think it's a little bit of a chicken and egg. We're trying to figure out what type of sample size do we need. We don't even know the sample proportion to begin with. We work ourselves around that by choosing the, quote, worst, the one that will produce the greatest standard error, and work our way through it. That conservative estimate leads us to the most conservative value for our sample size. It guarantees us that no matter what sample proportion we get, our confidence interval will live in this little 0.03 margin of error world. So that's it.